In this video, we are going to talk about percent increases and decreases, all as a part of percent change. Now, a percent change is an increase or a decrease given as a percent of the original amount. And we can find the percent change using this little formula. Percent change equals the amount of increase or decrease divided by the original amount. And this all comes down to reading the problem to make sure we know what is going on and what is the original amount. So let's jump right into a couple examples and see if we can calculate the percent change. In this example, we are being asked to find the percent change from 25 to 30. Now, we have our formula, which we remember was the amount increased or decreased over the original amount. So that's going to be our formula that we're going to use. And we have to really look at our problem and make sure we know what our original amount is. It says we are going from 25 to 30. Well, we are starting at 25 and we are ending at 30. So our original amount is 25. Now, to find our amount increased or decreased, we are going to do subtraction, and we always take the bigger number and subtract the smaller number. So I have 30 minus 25. So now we have it mostly set up. All we have to do now is move it off to the side and simplify. So 30 minus 25 is 5 over 25, which gives us the fraction of 1/5. But when we're talking about percent increases or decreases, we don't want our final answer as a fraction. We want it to be a decimal. And if we are good with our decimals, or we can divide 1 by 5, we get the decimal 0.25. Whoops, not 0.25, 0.2. And this is our percent change. The last thing we need to say is whether it was an increase or a decrease. And once again, we turn to our original problem. We started at 25, we went to 30, meaning this must be an increase because our value is increasing. So this is a 0.2 increase. And the last thing we need to do is, what type of a percent is 0.2? If we move our decimal 2 spots to the right, we get 20% increase. And that is our final answer. Going from 25 to 30 is a 20% increase. All right, let's try another one. Here, we are being asked to go from 200 to 110. Remember, our numerator is the subtraction of the biggest number minus the smallest number. So our numerator starts off with 200 because that's bigger than 110, and we subtract 110. So we have 200 minus 110. And the way to check that we've done this right for the numerator is that when we subtract, we should get a positive number. We do not want to get a negative number. Our denominator is the original amount, and since we're starting at 200 and going down to 110, our original amount must be 200. So when we subtract, we have 90 over 200, which, if we turn this into a decimal, becomes 0.45. And then we take our decimal and move it 2 spots to the right. So it becomes right there, and we have a 45%. And we ask ourselves, did we increase our value or decrease our value? We went from 200 to 110, so this was a 45% decrease. And there we go. Now, this is how we handle it if we're given both of our numbers, our starting number and our ending number, and we are asked to find the percent increase or decrease. But what if they give us the percent increase or decrease, and, well, they want to know one of the other numbers? Let's take a look at some examples to see how we would handle that. Now we are being asked to find the result when 10 is increased by 40%. So we know our starting number is 10. We know we are increasing its value, and we know we are increasing it by 40%, but we don't know what the final number will be. So we are going to have to first find out what is 40% of our starting number. So we are going to have to multiply 10 times 40%. Well, if we're going to multiply 10 times 40%, we're going to have to change 40% into a decimal. So I have 10 times, remember we have a decimal at the end of any whole number, move it 2 spots to the left, and we have 10 times 0.4, which when we then multiply it, we get 4. So 40% of 10 is 4, and we're being asked to increase 10 by 40%. Well, increase means we are going to have to add. We are going to take our original 10, we are going to add 4 to it, and our answer ends up being 14. And that is the answer to find the result when 10 is increased by 40%. Now, what if it was the other way around? What if it wasn't increasing 10 by 40%, but it was, let me cross this off, what if it was decreasing? What if 10 is decreased by 40%? Well, our first step would still be exactly the same. We find out what 40% of 10 was, and that was 4. But our final step, instead of 10 plus 4 for increasing, we have to do 10 minus 4 for decreasing. So I would have 10 minus 4, which would then be 6. So that's how we handle it if we are being asked to increase or decrease by a specific percent. We figure out what that specific percent of the number is, and then we either add for increase or subtract for decrease. Okay, we've talked about finding the percent increase. We've talked about finding the result after we've done an increase or a decrease. And what if we are talking about a discount? What if we went to the store and found out that one of our favorite items is having a percent discount? Let's figure out how we can solve for that final value. So let's say we're going to the museum. General admission price for the museum is $8, but if you have a student ID and show that you are a student, you get an automatic 15% discount. And we want to figure out, well, what is the price a student would pay? So, first thing we're going to do is very similar to the first step from last time. We need to find out what 15% of $8 is. So we'll set it up as $8 times 15%. That's going to be the same thing as 8 times 0.15, because remember, if we're going from a whole number to a decimal, we move the decimal 2 spaces to the left, and 8 times 0.15 is 1.20. So 15% of 8 is 1.20. And since we're talking about money, it is $1.20. Now we are talking about a discount price. So that means if I have a discounted price, I must be decreasing the original price. And how do we decrease the original price? We subtract. So I have $8 minus $1.20, which gives me the student price, and it ends up being $6.80. And this is the student price when the museum original price was $8 and students receive a 15% discount. We have one more example to do where we're talking not about a discount, but a markup. And if you understood how discounts work, a markup is the opposite. So let's take a look at this final example. Alright, here we are in our last example, where we are told a video game has a 70% markup, and the wholesale price is $10. Now you might be wondering, why is there a markup? Well, most stores, when they buy items that they're going to sell to regular consumers, they pay what is called the wholesale price. It's cheaper than the price they put on the shelves because this allows them to make back the money that they paid for it, plus a little bit extra, which helps them stay in business, pay for other workers, and other costs as they might incur. So you have a markup, which can be pretty much whatever the store owner wants, although there is something called MSRP, which is the manufacturer's suggested retail price, but we're not going to get into that. We just need to work on solving this problem. So we are marking up the wholesale price, which was $10, by 70%. Well, just as we've done in the past couple examples, the first thing I need to do is figure out what is 70% of the wholesale price. So I'm going to have $10 times 70%, which means we have 10 times 0.7. Since, as we've done this in the past two examples, and I'll do it again, I have a whole number 70, which means my decimal is at the end, and I can move the decimal 2 spaces to the left to make our decimal 0.7. And when I multiply 10 times 0.7, we get 7, which means it is a $7, or $7 is the 70% markup. Now, just like how discount meant we were subtracting from the regular price, markup means we are going to add to the original price. And since the wholesale price was 10 and our 70% of 10 was $7, we take $10 and we add $7 to it to give us the selling price of $17 even. And there you have it. I hope you have found this video useful. You now hopefully have a better understanding of percent increase and decrease, as well as how to figure out discounts and markups. Good luck with your future problems.